lesson 3.3/3.4, which is modeling with functions. And we'll start with a couple of vocab words here. The first one is a dependent variable, and this is going to be an output of our function. And normally the dependent variable is going to be our y value. The next one that we have is an independent variable. This is the input of the function, and this is going to be our x value. Next, we have function notation, and this is just a different way to write these equations, different notation. And you may have seen this before. It looks like this, f of x. That's how we pronounce it, f of x. And oftentimes, they'll write a number in there instead of a variable, right, which is telling you what your independent variable is and what you're going to be plugging in there for that independent variable. You may have seen an equation look something like this. Along those lines, and in this case the f of x is function notation, but it's basically the same thing. It's interchangeable as if they were to put y there. All right, so those two things are pretty much the same thing. It's just different ways to write it. All right, let's go ahead and identify some dependent and independent variables. It says in the winter, more electricity is used when the outside temperature goes down, and less electricity is used when the temperature rises. So we have two variables here. We have electricity and we have temperature. Those are the things that are changing. And in this case, the electricity depends on the temperature, right? If the temperature goes up, then the electricity increases, right? And vice versa. So in this case, we've got it written here that the dependent variable is electricity and the independent variable is temperature. Next, we have the cost of shipping a package is based on the weight. So we have cost and we have weight. And in this case, the cost depends on the weight, right? If it's heavier, then it costs more. So the cost depends on the weight. And so the cost is the dependent variable and the weight is the independent variable. Moving to the next one, a little bit trickier here. It says the faster Tom walks, the quicker he gets home. So in this case, the time that he gets home depends on his walking speed, right? Because if he walks faster, then he'll get home sooner. If he walks slower, then he'll get home later. So in this case, the time he gets home depends on his walking speed. So the walking speed is the independent variable. All right, we'll go ahead and write a couple equations here. It says Amanda babysits and charges $5 per hour. And we would identify the dependent variable and the independent variable. Okay, so the independent variable here is going to be the hours. And you'll notice oftentimes the independent variable is going to be time, right? Something that we can't control, also temperature. And in this case, that's going to influence how much she makes or her earnings. So her earnings depend on the number of hours that she works. It says let H represent the number of hours worked. Okay, so we'll go ahead and write this function here. So I'm going to write f of H, that's the function notation, right? H is our independent variable, equals, it tells me $5 per hour, so that's 5H. And that's all I need for the function there, right? It says if she babysat for 4 hours, how much money did she earn? So this is looking for F of 4. And all that means is that we're going to plug in 4 for H. Right, this is just notation. It doesn't mean anything mathematically. We don't need to do any multiplication or anything like that. It's just telling you plug in 4 for your independent variable, in this case, H. So we're going to do 5 times 4, which is going to give me $20. All right, we'll move to the next one here. It says a lawyer's fee is $180 per hour plus a $100 base fee. Okay, so again, we've got two variables here. So this is going to be the earnings of the lawyer and the earnings depend on the number of hours worked. So we've got our dependent and independent variable. The earnings depend on the number of hours that you work. Let H represent the number of hours. So we have F of H equals, in this case, it's $180 per hour. So 180 H, a little bit more expensive than the babysitter. And then it says plus there's a $100 base fee, right? So I need to do plus $100. And that's not per hour, that's just a one-time charge. So we just add $100 to the earnings there. It says if the lawyer worked for 7 hours, how much money did he charge to his client? So we're going to say F of 7. So we have 180 times 7 plus 100. Okay, so we can start to multiply those there. So let's see, that's going to be 1,260 plus 100 is going to give me $1,360. All right, we'll keep going here. It says the admission fee at a carnival is $9. Each ride costs $175. Okay, so for this one, this is going to be the cost of this trip. The cost depends on, well, we have to see what's changing here, right? What could change? And that's going to be the number of rides that I go on, right? Because each ride is $175. So the cost depends on the number of rides. Let R represent the number of rides you go on. So I'm going to say F of R equals, so it's $175 for each ride, plus we have a one-time fee when we enter the carnival of $9. It says if you go on 12 rides, how much did you spend total at the carnival? So that's going to be F of 12, which is going to be 1.75 times 12 plus 9. And then you just go ahead and multiply that out there. Okay? And I'll let you go ahead and work that one out on your own and finish it up. All right, keep it going here. Scrolling down to letter D. It says Matt earns $8.50 per hour proofreading advertisements at a local newspaper. He works no more than 5 hours per day. Okay, so again, his earnings, right, the amount that he makes, depend on the number of hours that he works. It says write a function here, so we use some function notation. Okay, so I'm going to put F of H equals, all right, tells me $8.50 per hour, so that's 8.5 H. All right, and he doesn't get any other fees or anything like that, so it's just going to be 8.5 H. But then it says, what is a reasonable domain for the function? Remember, the domain is going to be our independent variables. Those are our inputs. We talked about that yesterday. So I have to figure out what's a reasonable domain. Okay, and domain is the hours. So what's the minimum amount of hours that this person could work? And that's 0. That's the minimum. And it tells me he works no more than 5 hours, right? So 5 is going to be my maximum. And so H has got to be in between 5 and 0. And so we're going to use a compound inequality to represent that, where the maximum hours is 5, the minimum hours is 0. It says, given the domain, what would the range set be? Well, now I'm going to take these numbers and I'm going to plug them in for H and evaluate. Okay, so if I plug in 0, well, the least amount of money that he can make is $0. And the most, if he works all 5 hours, I would do 8.5 times 5 would give me 42.5. And so F of H has got to be in between 0 and 42.5. And then we move to this bottom one here. It says Tanya is printing a report. There are 100 sheets of paper in the printer, and the number of sheets of paper P left after t minutes of printing is given by this function. Okay, so this part's kind of tricky. P represents the number, the amount of paper that is left in the printer. So P represents how much paper is left in the printer. It says how many minutes would it take for the printer to use all 100 sheets. So it's basically saying we're using all of that. Remember, P represents how much is left. So at that point, there would be 0 sheets of paper left, right? Because we used all 100 sheets. So I'm going to plug that in for P. That's on the left side of my equation, equals negative 8t plus 100. And then we can go ahead and evaluate this. So subtract 100. We get negative 8t equals negative 100. Okay, and then from here, we'll go ahead and divide by negative 8. Okay, we got a negative divided by a negative there. And so hopefully this is going to give you, let's see, 12.5. Okay, and it says what's a reasonable domain for the function? Remember, the domain is my independent variable, so in this case the domain is going to be my t, right? And t is time. Okay, so the least amount of time that this is going to take is 0. And the most amount of time to use all the paper, well, we just figured that out, is going to be 12.5. So that's the reasonable domain. It says, given the domain, what's a reasonable range? Well, remember, the range, that's the dependent variable. That's going to be the P, right, how much paper is left. So if we're talking about the least amount of paper that can be left, well, that's 0 sheets. And the most amount of paper, well, that's the 100 that we started with. So P has got to be in between 0 and 100. All right, we'll keep moving here. In the next section here, they're giving you a domain, and then they want you to take that domain and plug it into your function here. So you can see I've already done that for the sake of time. I've taken 0 and I plug it in for x, right? And then I've taken 3 and I plug it in for x, because remember, domain, that's the inputs, that's usually the x value. And it says right here, plug in domain value for x, and then we evaluate. And when you do that one by one, you see we get these outputs here, which I've listed as XY ordered pairs here. So when I plugged in 0, my output was 5. When I plugged in 3, my output was 4. When I plugged in 6, I got 3, and 9, I got 2. And then sliding over here, we just plotted those on the graph there. So 0, 5 put me right here, and then 3, 4 right there, and then 6, 3, and 9, 2. So you can go ahead and pause this and fill that out, right? I think we're pretty comfortable with, so that's why I went pretty quick through that part. Graphing functions with a domain of all real numbers. So it's got some steps here. It says, if they don't give you a domain, then you select the domain values. So that's up to you, right? You select the domain values and you get to choose them. So what I'm going to do is I'm going to select my domain here. My domain values should be my x's here. So that's going to be -2, -1, 0, 1, and 2. I like to pick some negative numbers and some positive numbers when I choose my domain, and I usually have 0 in the middle there. And then it says, input those domains, input the domain values into the function. So we'll go ahead and do that. I'm going to input these one by one into x. Okay, so I'm going to end up with 2 squared as my first one, which is going to give me 4. 1 squared, which is 1. 0 squared, which is 0. -1 squared gives me +1. And -2 squared gives me +4. And then I can put those onto the graph there. So let's see. 2, 4. 1, 1. 0, 0, negative 1, 1, and negative 2, 4. And we end up with this beautiful graph here. Moving to number 3. Number 3 gets a little bit trickier here because notice we don't have a y equals equation. So what I'm going to do first is I'm going to go ahead and rearrange this. So I'm adding 2x to both sides. So I get negative 5y equals 2x plus 10. And then I'm going to go ahead and divide by negative 5. And so I end up here with y equals negative 2 over 5x minus 2. Okay, so we've got kind of a nasty fraction here. I'm going to pick some domain values. And I'm going to look at my denominator here, and I notice that my denominator is 5. And so if I pick multiples of 5 for my domain, it's going to make things a lot more simple for me. So I'm going to pick my domain as negative 5, 0, and positive 5. And then I'm going to plug those in for x one by one. So I'm going to plug in negative 5 for x one by one. And so I'll do that over here. So we're going to end up with y equals negative 2 over 5 times negative 5 plus 2. Nope, that's a minus 2. And then we'll go ahead and evaluate here. So that's going to give me a positive 10 over 5, which is just 2, minus 2, which gives me 0. And then I'm going to continue to do this. So the next one, if I plug in 0 here, I end up with a negative 2. Okay, and if I plug in 5 here, I end up with a negative 4. Right, and I'll let you do that scratch work on your own. So we ended up with negative 5, comma 0. 0, negative 2, and positive 5, negative 4. And we end up with that beautiful graph there. Right, we can connect those points. Okay, and we get this nice looking graph. All right, moving on to the next one here. We've got y equals negative x squared. Again, I'm going to choose my own domain values here. So I'm going to choose negative 1, 0, and 1. Right, I'm just choosing 3 right now for the sake of time, but it might be a good idea for you to choose 5 different values. And I'm going to plug these in here. So check this out. It's negative x squared. So I'm going to do negative 1 squared. And then that negative that's in the front of the parentheses just stays there. Negative 1 squared, so just this part here, negative 1 squared gives me a positive 1. And then that negative gets tacked on, so then it ends up being negative 1 there. If we go to the next part, y equals, that negative just lingers in the front, 0 squared, well that's just going to give me 0. And then lastly, y equals, negative stays in the front, 1 squared. Well, 1 squared is just 1, but that negative is still lingering there, so this turns into negative 1. And then onto the graph here, negative 1, 0, 0, and 1, negative 1. And we get this upside down U-shaped graph. All right, we'll finish this up here. It says find the value of f of x when x equals 4.5 in the function. So all they want me to do, and we did this before, is just do f of 4.5. So I just plug that in here, 5 times 4.5. Okay, and then that's just going to give me 22.5. And so that's all I'm really doing for all of these here. Scrolling over, okay, when x equals negative 2 for this one, so f of negative 2, that equals 1/2 times negative 2 squared. I'm going to do the negative 2 squared first, so that gives me 1/2 times 4, and then 1/2 of 4 just gives me 2. Keep it going down here to number 9. This time I'm plugging in 1/4. So I'm going to have f of 1/4. So that's 8 plus 4 times 1/4. Well, that's just going to reduce to 8 plus 1, which just gives me 9. I know I'm going quick here just for time. You can slow this down, right? Pause it and try it on your own. And then lastly here, we'll go to f of 20. So that's going to be 3,000 minus 70 times 20, which is 3,000 minus, let's see, that's going to give me 1,400, which is going to give me 1,600. All right, thanks for watching.